Algebra 1, Day 75. Today we're going to be talking about graphing exponential functions. So there's not much pre-work to do, so let's go ahead and jump directly into the notes. First thing, a y-intercept is where the graph crosses the y-axis. Another term that we need to be familiar with is asymptote. And yes, I know that's a very interesting word. This usually refers to a line that a curve approaches as it heads towards infinity, but never touches or crosses. It's written as y equals a number. My domain is the x values of a function. Unless otherwise stated, the domain of exponential functions is all real numbers, sometimes written as that little r, which can be written in interval notation as this. Remembering that we don't put those extra lines because you can't really be equal to infinity. My range, on the other hand, is the y values of my function. My range, or lowest, highest values in the graph, are determined by the asymptote. So, I will show you what we mean here in just a second. So let's go ahead and take a look at the very first problem. So here they gave me an equation. My equation is 1 times 2 to the power of x. So I'll start here at 0. 2 to the power of 0 is 1 times 1 is 1. And I'll keep plugging that in over and over. Now, I want you to notice a pattern, and this is going to come up later, and it's going to help you. So here it's 1 times 2 to the power of 1. That's 2, 4, 8. Notice how every time we are multiplying by 2, just like a geometric sequence. And if I want to head in the opposite direction, divide by 2. I don't even have to do the math. Okay? So let's go ahead and graph this guy. So first of all, at negative 2, it's going to be somewhere here. Negative 1. At 0 is 1. At 1 is 2. At 2 is 4. And at 3 is 8. And I want you to notice this. So if I look at from 0 to 1, I multiply by 2, multiply by 2, multiply by 2 to get the next y value. Now these graphs are always going to look like this, kind of a stretched out half of a U, okay? Now, before we continue on, what I do want to make note of is where is that asymptote? And instead of me just drawing it on here, what I would like to do is go ahead and plug this into my calculator. So I'm going to go ahead, I'm going to graph this one. Okay? Now I'm going to go ahead and look at my table. So an asymptote is a line, usually not drawn, that some type of graph is approaching and getting really close to, but it never actually touches, okay? So if I look over here, it looks like my numbers just keep going up, 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 in the positive x direction. However, if I go over here, they go down, but it looks like they're going further and further down And they're heading towards 0, but they never really became 0. So my asymptote would be located at y equals 0. And that would be located here at the x-axis. That would be my asymptote, that blue line, okay? My y-intercept, where it touches my y-axis, is located at 0, 1. My domain, all real numbers. My range, I always look at my asymptote. Here, it's on top of my asymptote, so it's y bigger than 0. No extra line. Never an extra line for exponentials. And that's it. That's an exponential graph. Let's go ahead and take a look at another example. All right. First thing, I see -4 times 2 to the power of something. All right, so I'm going to go ahead and plug this in. So as you can see, every single time it's multiplying by 2. So if I want to head in the opposite direction, divide by 2. All right, so it looks like if I'm just looking at these values, it's heading towards 0. But these numbers are all below 0 on the y-axis. So this would probably have a range of y less than 0. Domain, all real numbers. Asymptote, y equals 0. My y-intercept, 0, -4. So we can get all this information just by looking at a table of values. But let's go ahead and graph it anyways. So 0, -4, -1, -2, -2, -1, -3, -0.5, 1, -8. And I'll go ahead and graph it. Now these are kind of hard to graph because we really can't graph that exact. All right, there's that. And my asymptote is, of course, located here at y equals 0. Simple. All right, let's go again. Remember, just like geometric sequences, except this is not n minus 1, it's just x. No -1. So let's go ahead and get started with this one. Start here with 0, 3 times 1/2 to the power of 0, 3. 3 times 1/2 to the power of 1, 3 halves. 3 times 1/2 to the power of 2, 3 quarters. 3 times 1/2 to the power of 3, 3 eighths. Notice, what am I doing? Dividing by 2 every time, right? Or multiplying by 1/2. In the opposite direction, multiply by 2. That is important. These are kind of like ratios, just like geometric sequences. So let's go ahead and graph these. So at +3, I have really small number, +2, there somewhere, +1, at 0, at -1, and at 2 is going to be way out there. So my graph is going to look something like this. And again, it doesn't have to be exact. Okay, let's go ahead and draw in that asymptote. And it's located at y equals 0. So my y-intercept is located at 0, 3. My asymptote at y equals 0. My domain, all real numbers. My range, it looks like my y's are on top of my asymptote. They are bigger than 0. We're good. All right, guys. All right, so I want you guys to go ahead and take a look at the example problems, and I will see you next time.